I've been wasting some time. Okay, so here we go. Section 1.3. Some of you already turned in your homework. That is great. It's not due right now. But I love it. You just need to get it in by the next 3 or 4 days. So probably by Wednesday, if you get it in, that's about right where you should be. So if it's already in your head, if you haven't started it at all, I'd look into it. Okay. You know today was a success when you can distinguish between an intensive and extensive property. We barely scratched the surface of this. And then the bell rang. And then explain how to separate substances based on physical properties. The next time I see you is Tuesday, right? Monday's Labor Day. We're going to do a lab on Tuesday where we separate things based on their physical properties. I don't know, it's not a super hard lab. It's not like an explosive lab, but it's kind of interesting. And hopefully if I stop killing time, we can talk about it. All right, so these are still the homework problems. If you would please read the rest of chapter 1. Now, just a review on how to find all that. So you go to Canvas. Then you go to your AP class right here. Then you have the welcome and Zoom link. So if you're ever gone, you can click the Zoom info and we're right here online right this minute. All right. Then if you want the link to the whole textbook, it is there. The AP chemistry syllabus, almost all of you have turned that in. All right. Then you come down here. You don't see this, but you have chapter 1 essential ideas. I just added this morning. That's a link you can click just to take you straight to the PowerPoint that I'm using right here. All right, if you want it, it's there for you. All right, so that's at the, why did I have such trauma trying to figure out which way to go back? There was 3 ways to do the same thing and my mind exploded. Did you see it? Like, oh my God, I don't know which one. All right. When it says chapter reading 1 assignment, that sounds, maybe that's poorly named because that's not like a homework assignment. That's just the reading that I want you to do. It's just chapter 1. It's the same thing as in the textbook. It's just linked on a page. So there you go. That's okay. Come back. There you go. That's what that is. So that will always take you to the chapter we're on. Percent error supplemental instruction. We're going to talk about that later in the week. This is the lab report that we're going to do. So we'll talk about that Monday. Here's your elements and polyatomic ion memorization. That takes you to the Quizlet. Chapter 1 practice problems. That once again takes you to the same place that the overall textbook takes you to. It's just in one cleaner PDF version. On all those practice problem pages, it will also tell you the ones that you're required to submit. I recommend you do as many as you need to get smart, but you don't have to turn all of them in. If you do more than I ask, you don't have to have a separate paper where you do everything and you submit only these. You can just take a picture of everything if you want. You don't have to separate it out. Chapter 1 class recordings 2021. You don't see this one on your end anyway, but this is where I post what we did. So if you were gone, you can go to this link. You can watch the thrilling video from 2 days ago, just right there. Yep, bubbles. That's me. Okay. I'll review Canvas a few times. It's extremely likely that at some point in this trimester, you're going to be sick or gone or not want to wake up. Well, this is 4th hour. I keep forgetting. Use this. If Corona has done one good thing for your life, it's made it extremely easy to be a remote learner. So take advantage of that. But for me, it's also made it nice where I can shift all the burden to you if you're gone. Like, hey, I put everything there. If you miss a day, it's up to you. Okay, that I took too long, but that's kind of how that goes. All right, let's roll. We're going to talk about intensive and extensive properties again. I cleaned up the notes a little bit. Intensive, independent. meaning it doesn't matter on the amount of the substance for that property. So density, boiling point, color, etc. So in this sulfur sample right here, tell your partner at least one thing that is an intensive property of those two things. All right. The density, I heard the melting point. What else? Nice. All of these are intensive properties. We could have a little bit of sulfur or a giant amount of sulfur, and all these things would be the same, correct? Because those properties are independent of how much there is. But now we have extensive properties that do depend on the amount of the substance present. So that would be like its mass. If I have more sulfur, it has a greater mass. If I have more sulfur, it occupies a greater volume. Energy, sulfur we don't really use for energy, but if I have 2 gallons of gasoline, I can go twice as far as I can 1 gallon of gasoline. All right, and that's common sense. All right, so a little bit blurry here, but the difference between extensive and intensive properties of matter in this picture are illustrated because they differ in size. The 2 samples of sulfur have different extensive properties such as mass and volume. In contrast, the intensive properties including color, melting point, and electrical conductivity are identical. Okay, the book has this section's really good right here. Right here. This is from the online textbook. I love it, and this is what I think is really cool. It says, although mass and volume are both extensive properties, their ratio is an important intensive property called density. So we can have things that are intensive that come from ratios of things that are extensive. It's because they change at the same rate. But anyway, that's right in your book. You can make an account if you feel like it, and you can highlight, you can annotate, you can do anything to the notes and save them. You don't have to do that, but that is an option. But please use the book. It has some pretty good stuff. This whole section right here is a good way to talk about intensive and extensive properties. All right, coming back here. All right, so changes of matter. We have physical changes and chemical changes. This is like kindergarten chemistry on this part, so I'm not going to spend too much, but we have the physical change. We already kind of said it, but it's changing matters that do not change the composition. So changes of state, temperature, volume, stuff like that. It didn't really change its chemical composition. So if I have a piece of paper, what is this piece of paper? Oh, wow, I counted really well. I have one extra. If I take this piece of paper and I change its size, did I change its composition? No, it's still paper. It's just 2 pieces. They're smaller. All right, if I burn it, did I change its composition? Yeah, I got heat, light, smoke, a little bit of ashes out of it. Anyway, so physical, it doesn't really change the substance that much. Chemical changes that result in a new substance. So like combustion, that means burning. Oxidation is an exchange of electrons. Like rust is oxidation. Decomposition, that's when something breaks apart, and etc. So if it changes the chemical structure, then it is a chemical change. I'm going to move on in 30 seconds. So if you're writing that one. They're also in the book. Whenever I say the book, I know it's online, but like it's right in through here. So you can definitely read the textbook and have the same information. Someone say something? Okay. All right, moving on. So we're gonna spend the entire year on chemical reactions. So don't you know, I even write this slide, but chemical reactions. So when we have a chemical change, we have a chemical reaction. In a chemical reaction, the reacting substances are converted to new substances. Now, I would have you memorize 2 new vocab words, and they're really not that crazy. In the course of a reaction, the reactants are converted to products. So you should know in a chemical reaction, our reactants are what we start with, and our products are what we end with. So yesterday, 2 days ago, whatever, when we were together, I did electrolysis. My starting substance was what? Is water. So over here I'd have H2O, and then I'd have my arrow. And what were the 2 products? All right, H2 plus O2. Then we realized, oh, this is really not balanced. So it was a 2, and a 1. And we'll learn a ton about balancing. What? A ton about balancing, and a ton more math. And we're going to enjoy it, every second of it. Okay. So the left side, reactants, right side, products. All right. Compounds. Compounds can be broken down into more elemental particles. So this is just another definition, essentially. And these are things I hope you learned in 7th or 8th, 9th grade. So we took the water compound and we used electricity to break it apart. When water is formed, it's the reverse reaction. And remember that sound when I lit the hydrogen on fire? That was the sound of water being formed. All I did was reverse it, because water is how oxygen and hydrogen want to be together. So the reverse reaction, H2 plus O2 goes to H2O. When this happens, there's actually an exchange of an electron between the 2 of them. And then it's really happy. Oxygen takes an electron, it shares it, but it doesn't share equally. So the electron sort of moves closer to oxygen, and life's fantastic. All right, that's how nature wants it to be. But if I do work, I can reverse how nature works. So that's why in electrolysis, you have to plug the machine in so you can fight nature and make the electron go in the reverse direction. So anyway, that wasn't super important yet. All right. Well, we don't need money yet, but you're going to be asked to sign up for the AP test pretty soon. Just heads up. All right. Moving on, we've got separation of mixtures. All right. This is actually really important. There's a fairly high chance on the actual AP test in May that you'll have a question where they want to see if you know how to separate a substance based on its physical properties. And you're going to learn it on September 3rd. So that's a long time to remember things. The reason they like these questions is that you can draw, you can describe a lab, you can list the safety requirements, and you can then describe exactly the steps you would take. AP loves lab-based questions. You'll have one no matter what. You don't know what it's on. But where you can draw and explain pretty clearly, they'll do it. All right, so we're going to talk about separating mixtures. Mixtures are physically blended substances. Like trail mix is a mixture. It's got peanuts, it's got raisins for some reason, and it's got M&Ms and maybe some granola. I don't know. Okay, I don't eat trail mix. It's too healthy. Yeah, whatever. But you, if told to, you could separate it into its parts, right? You would just move all the raisins to the garbage, all the M&Ms to your belly, all the peanuts to your belly, and then all the other material probably in the garbage too. But anyway, you could separate it using a physical process, not a chemical one. You don't light trail mix on fire to separate the parts. We use a physical process. All right. So I'm going to ask you to make some basic drawings today. Don't make them perfect like you're going to see on the screen. but there are a few ways that we use to separate mixtures. Now, this would be a mixture like that's a solution. This is called distillation, and you don't have to draw it exactly perfect. Draw some sort of heat source. So this is the Bunsen burner. All right, you have this and it has your solution in it. And then you have this tube, and this is corked. This is where the gases cool down and they're separated out. Now, you could have that in different places. It doesn't really matter. But what we're doing is we're taking advantage of the differences in boiling point to separate out the parts of the solution. So I don't know how well you can see that, but it says salt water. Water and salt have extremely different boiling points. So all I have to do is heat that to the boiling point. The water turns to steam and leaves any of the salt still in the Florence flask on the left. Eventually, all the steam leaves, and all you would have left is salt in the end. You would just have salt stuck to the bottom here. Then the steam as it traveled through here would have been cooled, and it would have come out. So you'd have your salt separate and your water separate because they have different boiling points. Whenever you drive to Salt Lake, you go past the Holly refinery in Woods Cross. All they're doing is taking crude oil and they're boiling it. Crude oil has a lot of different types of substances in it. So they heat it or they distill it. And in the distillation towers, the tall parts, they just have places where they take, all right, everything that boils at this temperature has this density of gas. We're going to make it leave here, here, and here. By the way, this would be like your 93 premium. This would be your 87, and this would be your 83 unleaded. The more it's refined, the more energy you get per unit out. But also it's more expensive. It takes more effort to refine premium gasoline than it does just your standard. Okay, so the key here, kind of know the drawing, know that distillation takes advantage of different boiling points. Fair enough? Okay, I'm going to move on. Same slide. All right, filtration. Filtration separates solid substances from liquids and solutions, and it really separates based on solubility. Have we defined what solubility means yet? Have I said that? It's not that hard to figure out, right? Solubility is the substance ability to dissolve. So we would say salt, it dissolves in water. So we would say it has a high solubility in water. But if we threw in like sand, we know sand does not dissolve. So we would say it is not soluble. So filtration, it's pretty easy. You got an Erlenmeyer flask or whatever right here. You have a funnel. You put in a piece of filter paper, and then you pour stuff through. The filter paper will take the solid that's not soluble, and it traps it in the filter paper. It lets liquid flow through. So anything that is soluble will be part of a solution, and it will go straight through the filter paper. All right. Now, in a solution, I keep talking about a lot of words that maybe you're not familiar with still. A solution is made up of two parts. That's the solute, which if it's salt water, that's the salt. The solvent, that's like the liquid part, that we put the salt in, and for here we would call that water. Together, they make a solution. Okay, so in the lab that you're going to do, you can keep writing or whatever. I'll just keep talking. In the lab, we're going to do when we're together on Tuesday, I'm going to give you a mixture of chalk, citric acid, sugar, and iron filings. And I'm going to ask you to separate the 4 of those into their 4 separate components. We'll have part of it be filtration. So you're going to have a piece of filter paper. I'm going to show you some magic, and we're going to put it in a funnel. So to do that, we take our filter paper, fold it in half, and then we fold it in half again. Then we open one side, not the middle like I almost did, and then it fits right in there. So we can use this exact setup. All I need is a Erlenmeyer flask. We'll pretend this is one of those. We'll have a little funnel rack. We'll hold it. We'll put the substances we want to separate into the filter paper, and then just wash it with liquids that the substances are soluble in. Kind of makes sense? So if I wanted, well, I'm not gonna, that would give you too much information, and I don't want you to just do what I say. I want you to think. Okay, filtration's pretty common, pretty simple. Go ahead. No, not really. But, well, you're going to use an Erlenmeyer flask like 2,000 times this year. So you won't have to memorize it. You'll just kind of know it. And the spelling is not important. Erlenmeyer spelled kind of weird. Phenolphthalein, that's something we'll use a lot. I don't know anyone that can spell that off the top of their head, but it'll be fine. You can just say flask. All right, so that's filtration. Now, distillation, remember I said you needed to know what it was and that it separates liquids, and it's based on boiling points. Filtration, you need to know what it is, like what it looks like. You need to know it separates solids from liquids, and it's based on the solubility. All right, chromatography. Chromatography to me is not really a separation process, even though it is a separation process, and I'll tell you why. Chromatography, it separates substances on the basis of differences in solubility in a solvent. So this is similar to filtration. All right, it's used for analysis, but not a true separation. And what I mean by that is that I can see that this black ink consisted of multiple colors. But if I separated those colors into something I can have. No, I've analyzed it, but I haven't really collected it. In a filtration, you'll literally have the 2 things separate. You can collect them, and then you can mask them and figure out stuff. This just tells you, hey, this is what's in it, but we can't analyze it any farther. So it is separating them, but not as usefully. All right, if you've had forensics, you do a lab with chromatography. We'll do one significantly later in the year where we try and analyze what we've got. So what will happen in chromatography, you take a piece of filter paper again, this time they're cut into strips. You put your source, so just black ink or whatever, it could be blood, it could be whatever you want it to be. And then you put this piece of paper into a solvent. And is it capillary action? I'm pretty sure. Causes the solvent to travel up the filter paper. If things in this are soluble in this liquid, then they'll travel together. It'll pick it up like a little bus ride. All right, and over time, things will go up. Okay, we haven't had a lot of discussion today, probably boring, but here's your real question. Based on this data, I want to know, you got blue at the top, you have pink, sorry, purple, whatever color you call that. I have color issues. All right, at the bottom, I want you to talk to your partner and tell me which one of those is the larger molecule. And then tell them why. Which one's larger? All right. I talked to a couple groups. They were both right. Their reasoning was slightly different than each other, but basically the same idea. All right. So if we had to say just best guess, which one do you think is the large one? Purple. And small then? Blue. Right. That's true. That is 100% the right answer. Right? They are both soluble in the solution. If they weren't, it wouldn't have gone anywhere. Okay, so both of, I should say solvent. I will say that wrong a few times. They're both soluble in the solvent. We know that because they both move. So the only difference then must be, all right, well, this one's probably larger because it was harder to move up than the blue. The blue traveled farther. So we guess this is the smallest, or another way to say it is it's the most soluble to least soluble. And typically that's dependent on size. And we'll learn about it. They're called the intermolecular forces. There's a whole chapter on that as well. But anyway, we can analyze that. So if you ever get a handwritten note and you want to know if it's from your best friend forever, bring it to me. We'll steal his pen and we'll put a dot and we'll see if they're the exact same. Sound good? Super easy. All right, or take it to Harding and she can fingerprint it for you. Maybe that's the easier thing to do. All right, so there we have chromatography. It separates things based on their differences in solubility in a solvent. Okay. Now, this is the lab that we're going to do. So the way you turn this lab in is like your homework. You take pictures of it and then upload it to me. So I would start on a whole new page. You don't have to rip it out and turn it in. You can upload it. So put this on a whole new page. All right. So plan for today. It's all weird because of the way the days are, but who cares? SOS lab. SOS stands for Separation of Substances Lab. All right, the element quiz will be tomorrow, which is really Tuesday. If I ever say tomorrow or yesterday, I mean the last school day we were together. All right, so this is what we're gonna do. Draw this table for me, if you would. Then while you're drawing, I guess I should probably go get these substances out of the back room. I didn't think we'd get this far. Oh. I don't know. When do we? 45? Okay, so pretty soon. I guess I won't go get these substances out of that room. Oh, I will, but we'll see if we get that far. Hello, niece. All right, my computer is trying to load this. There we go. All right. Now, don't just copy this table down yet because it might be in a different order. This is a picture of a very large microwell plate. In the top row, I have water, and then I've added chalk to water, citric acid, and sugar. In this one, I have methanol, where I've added chalk, citric acid, and sugar. Now, looking at your data table, let's make sure it's oriented the right way so we don't write it the wrong way. I wonder if this will let me copy it into the other one. I think I copied the whole thing. We'll find out. Okay, Tom, then you just did that. All right, so it's a little bit tricky. So first off, the table you wrote and this picture are upside down. I feel like I said don't write anything down yet. All in favor that I was right, she's wrong? Okay, so here we go. Let's look, it's gonna be weird. Solubility in methanol of chalk. When things dissolve, they disappear in a liquid, right? Does chalk look like it went away in either liquid? No. So for chalk solubility, I'd put no and no. Chalk does not dissolve in water. Chalk does not dissolve in methanol. Okay, so we have a no and a no. Now, iron is not in this picture. We'll talk about that. I have 30 seconds. How about citric acid? It dissolves in both of them. So you'd have a yes and a yes. And then sugar dissolves in what, but not in what? It dissolves in water, but not in methanol. So I got a no, a yes and a yes, a no and a yes. And iron, by the way, it doesn't dissolve in either one of them, right? Now, the appearance, you can look at those on Tuesday. Maybe, what time we get out? I thought I said 45. Oh, boy. Well, we're not going until that bell rings. Okay, now, I want you to think about this and discuss. You have 4 things that you need to separate. They are iron, chalk, citric acid, and sugar. I'm going to give you these 2 liquids and then something else that you might be able to figure out. So have a discussion. How do you think you could literally separate the 4 substances from each other? Ready, go.